Hi and welcome to my YouTube channel. I hope you're having a blessed day. In this YouTube video, I'm going to be showing you how to use the Newton-Raphson method to solve any equation that's starting with f of x. In numerical analysis, you might be wondering what the Newton-Raphson method is. In numerical analysis, Newton's method, also known as the Newton-Raphson method, named after Isaac Newton, which is the first part of the name, and then Joseph Raphson, which is the second part of the name, which together forms Newton-Raphson, is a root-finding algorithm which produces better approximations to the roots of a real-valued function. Down here, we have the formula that we're going to use to find this. Here we have x of n plus 1. So after every time that we're going to use it, for example, in a question is going to ask you to find x of 4. And it's only been given x of 0. So in that case, we have to use x of 0, and then after each time, obviously it's going to be added 1, which is going to be x of 1, and then x of 2, and then so on. And then here we have x of n, minus f of x of n, and then down here is f derivative of x of n. As I mentioned, you're supposed to have a value as, for example, x of 0, which could be anything like 2, 3, 0, or even 1. If we are not given this value, then we're going to take two numbers and put it back into f of x. And if there is a sign change, then we're going to divide it by 2, and that is going to be our x of 0. So here is our example, which in this case we have f of x is equal to x squared minus 4. The first thing we're going to do is finding the derivative of f of x. And in this case, how to find the derivative, if you are not aware, you first of all write this. There's an apostrophe on the top of f, which means the derivative is equal to, you always take the power, which here is 2, and then you put it up front. If we were to have a number up front, then you times it. But since we have 1, 1 times 2 is 2, and then we place x, and then we always minus 1 to the power. In this case, 2 minus 1 is 1, so we don't write anything. And then we have a constant. Constants always become 0, so our derivative is only going to be 2x. And in this case, we've been given a value which is x of 0. x0 is equal to 3. So we're going to start, first of all, by writing our formula, which in this case is going to be x of 1 is equal to x of 0 minus f of x of 1, and then f derivative of x of 1, since we're going to find x of 1. And here at the top, it says use Newton's method to find x of 4. So we have to do x of 1 and then find x of 2, x of 3, and then finally x of 4. First of all, I've written the formula, and then we're going to find what we have. We're going to write what we have, So we're going to write our x of 0, which is 3, then minus. Here we have f of x of 1. So you can just take this and you write 3 squared minus 4, because that is our f of x. And then our f derivative of x is 2x. So we write 2 and then our x, which is 3. Here our answer is going to be 3 minus 5 over 6, which is also equal to 2 plus 1, 6, 6, 6, 7. If you do this on the calculator, you're going to get the same answer. So after we've gotten this number, we are going to do x of 2, because we are supposed to go all the way to x of 4. So we're going to write x of 2 equal to, this time it's not x of 0, it is x of 1. Then minus, same thing here, it's f of x2 over f derivative of x2. which is equal to our x of 1 that we found here is 2.16667. So we write 2.16667. Then we minus it by our f of x2, which here we have the formula of f of x, so we just place it here, but with the value of x of 2, x of 1. So it's square and minus 4. And down here we have 2, 7. What our result here will be is 2.000641. If you do this on the calculator like I have before, then you're going to get this number. Now we move on to x of 3. We write x of 2 minus f of x3 over f derivative x3. Once again, the value we found here, we put it here because it's our x of 2. So we're going to write 2 plus 0, 0, 0.0641 minus, once again, we're going to take this. This is a long number. And then we're going to write. Now I'm going to demonstrate this one time on the calculator for you guys. Minus 2.00641 to the square root of 2 to the power of 2 and minus 4, then 2 here you can see our result is equal to, obviously we're not going to write all of this, we're only going to take 4 zeros and the digit after, which is 1. So here we can write 2.4 zeros and then a 1. Sorry. And then for our last step, which is what we're finding is x of 4, we're going to do the same steps as we've done, but for the last time. Here we're going to do our value that we found here, and it's going to be f of x4 over derivative x4, which is then equal to, I'm sorry, not supposed to be there, 2.0001 minus, here we have 2.0001 squared minus 4, and then we have 2 point, don't forget that 2 before, 1. Now we're going to calculate that, which gives us a single value, which is 2. And this is how we use the Newton method to find any equation that starts with f of x. And I'm going to just conclude this lesson very fast. We use this in numerical analysis, and we can do this with a simple rule. This method can be faster than using the bisection method, the false position method, because this takes just a few steps, as you saw. If we use the bisection method, it's going to take a lot of iterations, which is very time consuming and just not good. So I'm going to run down for the last time what we did and recap this. So we always use this formula that we have here. Let me just put it in a bracket for you. And as I mentioned earlier, if you are not given x of 0 or x of 1 to start with, if you've been given x of 0 and then x of 1, but you're supposed to find another number, if you're not given that, then you take two numbers and you put it back into f of x, and then if there is a sign change, you divide it by 2, and that is your starting point. Using this formula, we put x of 0 here, and then f of x of 1, and then f derivative of x of 1. As I showed you here, this is how we found the derivative. And we repeat this as many times as we are required to do, and then we get the final result, which is in our case is 2. I hope this lesson has been very helpful and clear. Thank you for listening and watching my video. I hope you have a great rest of your day.